NASA's latest robotic lander, InSight, descends to the surface of Mars. A challenging effort greeted with elation.
Touchdown confirmed.
Meanwhile, an orbiting ESA satellite, ExoMars, begins its own exploration of this enthralling planet. The majestic stereo imagery of Mars as seen from orbit reveals a planet of dynamic texture and form, slowly revealing its secrets.
We've sent a lot of missions to Mars in the past. We've sent rovers, we've sent orbiters, they've done a lot of really great science and a lot of really interesting measurements, but those measurements just scratch the surface of Mars. We know a lot about the surface of Mars, we know a lot about its atmosphere, and even about its ionosphere, but we don't know very much about what goes on a mile below the surface, much less 2,000 miles below the surface down to the center. And this will be the first mission that's going to Mars specifically to investigate the huge extent of Mars below the surface. The basic idea of InSight is to map out the deep structure of Mars for the very first time. We're going to map out the thickness of the crust, the size of the core, the composition of the mantle and core of the planet, sort of get the first map of the deep inside of Mars. It's going to Mars to do the science, to make the measurements that scientifically and personally I've been waiting for over 30 years for. As a graduate student, I was doing research on Mars, and I just needed to have the thickness of the crust. I just needed the thickness of the crust, and we didn't have it. And seismology was the way to do it. And so I thought, well, maybe someday somebody will put a seismometer on Mars and get this measurement so I can do my research. And so it's kind of an amazing journey for me to look back and say, I'm the guy who's actually going to put that seismometer on Mars, get that information, and now I can go back and finish the job I was trying to do 30 years ago. It's an amazing feeling.
The InSight mission will finally provide seismic information of Mars that scientists have been wanting for since the very first Mars lander, Viking. It had a seismometer on it, but for a variety of reasons it never got back any seismic data. There's been many other attempts to get seismometers onto the surface of Mars for very good science reasons, but they've, for one reason or another, never been successful. So now we're right on the very edge of getting a seismometer onto Mars that will finally give us back seismic data. That seismic data is incredibly important to scientists because it gives them an idea of what the size of the crust, the mantle, and the core are, as well as the properties of each of those, which are the basic internals of every rocky planet.
The most fun or interesting thing about InSight from an engineer's point of view is really that we're playing the claw game super far away on Mars. We're taking this grapple and we're going to pick up an instrument and lift it up off the deck and put it down on Mars. So I like to say that we're playing the claw game on Mars with no joystick.
Next, a wind and thermal shield will be lowered over the seismic instrument to protect it from the environment. The second instrument, the heat flow probe, will be placed on the ground and over time will hammer itself down to take subsurface readings.
There's a lot of international partners on InSight. It really takes a whole world to produce an exciting mission like this. So most of our science missions are actually being supported by our international partners. So for example, the SEIS instrument, our seismometer, has support from the French, the Germans, the Swiss, the UK folks. So we have a variety of those people. The heat flow and physical properties probe is being provided by the Germans with some support from Poland.
InSight is a mission to Mars, but it's much, much more than a Mars mission. In some sense, it's like a time machine. It's measuring the structure of Mars that was put in place 4.5 billion years ago, so we can go back and understand the processes that formed Mars just shortly after it was accreted from the solar nebula. By studying Mars, we'll be able to learn more about Earth, Venus, Mercury, even the Moon, even exoplanets around other stars.
ESA's Trace Gas Orbiter mission arrived at Mars some time ago. Since then, this 3.5-ton spacecraft has been gently brushing the atmosphere to gradually adjust its orbit. In ESA's Planetary Missions Control Room in Darmstadt, Germany, flight controllers have been checking systems and commissioning instruments on the ExoMars Trace Gas Orbiter. Now it's ready to begin its science mission.
It has been a long time since we arrived at Mars in October 2016, and we have had a long, very long period, 1 year, of aerobraking, which consisted in reducing the orbital period from the time when we arrived, where it was actually several days, to 2 hours, which is the nominal period for science observations. I'm looking forward to the next few months enormously because the TGO will finally be able to show its full capability, the full capability of its instruments in terms of accuracy and the quantity and quality of data, pictures, spectra. And also because we will be able to do joint observations with our previous spacecraft at Mars, Mars Express, which is still alive and working after 15 years actually. And for ESA having 2 spacecraft around Mars in complementary orbits from a scientific point of view is very exciting and will allow certainly some very interesting discoveries and observations.
ExoMars will fill a double role when its partner rover is dispatched to Mars in the coming months in the search for life on the dusty planet.
It is a communication satellite on top of being a science orbiter. The so-called relay function allows us to communicate with all landers and rovers on the surface of Mars. At the moment, there are only rovers and landers from NASA, Curiosity and Opportunity. Some tests had been done already soon after arrival at Mars. And now we are going to start a campaign to calibrate and determine the best performance to relay data.
The Trace Gas Orbiter's primary mission, however, is to identify gases in the Martian atmosphere, particularly methane. First hinted at by Mars Express, and then by NASA's Curiosity rover as it sniffed the atmosphere with special sensors.
Well, we know that the lifetime of methane is very short, just a few hundred years. It will be broken down by the sunlight, by the UV ultraviolet component of the sunlight. So if it is there now, we know that it has to be refilled all the time. And where does it come from? That's the big question. It cannot be synthesized really in the atmosphere. It has to come from the surface or from the subsurface. But what are the processes that produces it? This is what we want to find out. One possibility is that it is some geological reaction between minerals and water. Another possibility is that actually also are microbes down buried underneath the surface that is producing it today or has produced it a long time ago, and they're all dead now, but that the methane has been kept underground and with some mechanism is released to get up into the atmosphere. So these are all these kind of things we try to find out.
By using the orbiter's powerful spectrometer, scientists hope to discover whether the methane comes from a geological or biological source. 95% of methane on our own planet comes from living organisms. The ExoMars rover, landing in 2021, will drill up to 2 meters beneath the surface to search for this evidence of life. And the rover, as well as NASA rovers and landers, will use the orbiter to keep in touch with Earth. Mars exploration is an international endeavor, and every mission adds to our understanding of this alien world, a place that some of us might someday call home.
Planetary exploration is always very exciting, but Mars, of course, has this very special thing, is that there is actually a place that you can imagine yourself walking on. You eventually, within not too far in the time in the future, surely people will be walking on Mars. And that makes it very exciting. And then to think about this idea that there might have been some kind of life or even exist today underground on Mars, that makes it a very special place.
Curiosity landed in Gale Crater on an ancient lake bed. A few months after arrival, it drilled into sedimentary rocks and detected traces of organic molecules using an instrument called SAM.
Well, the SAM instrument detected a variety of organic molecules in a sediment that is from an ancient lake bed in the middle of Gale Crater. And what's important about these is that we now have a lot more certainty that there's organic molecules preserved at the surface of Mars. We didn't know that before. But what's interesting is that we don't know what the source of these organic molecules is right now. There's just not enough information from that. However, if we drill deeper and we look around a little bit more, we might actually be able to get to that information and tell, did they come from life? Did they come from geological processes? Or maybe they were from meteorites that were deposited in the lake. We just don't know right now, but hopefully we'll figure that out.
Curiosity is searching for carbon-based organics.
Sam made the new detections by heating samples of crushed rock to very high temperatures, above 1,000 degrees Fahrenheit. This vaporized the samples and released several species of small hydrocarbons like benzene and propane. Because the hydrocarbons were released at such high temperatures, they may be the fragments of bigger, heavier molecules within the rock similar to kerogens. On Earth, kerogens are found in rocks like black shale and coal and are the products of ancient plant and bacteria.
Some other organics have been detected, like thiophene, which contains sulfur. Introduced by geological processes, this sulfur acts as a preservative, binding organic molecules together and making them resistant to oxidation, so preserving them for millennia.
Organic molecules could be the food for life, or they could be the product of life, or maybe they're from something altogether different, such as geology or meteorites that were deposited into the lake. We don't know what the source is, but there's a story there, and we're going to uncover what that is.
Scientists still don't know if the discovered organics on Mars are biological in origin, but it's exciting to find such old material preserved right at the surface. This finding is also encouraging for future exploration. So for a time, curiosity continued to travel, find interesting outcrops, drill holes, take samples. Then, inexplicably, something went wrong.
The drill's feed mechanism, which is responsible for moving Curiosity's drill bit into and out of rocks, didn't move when commanded. When Curiosity drills into a rock the way it was designed to, the drill's two stabilizer posts touch the rock first to steady the arm while the drill's feed mechanism moves the bit forward into the rock. Without the feed mechanism working, we can't drill that way. To solve this problem, we do what we always do. We worked it out in the test bed using Curiosity's twin on Earth. Our team of engineers and scientists have been working for months to figure out a way to collect and deliver rock samples without using the feed mechanism. Here's what we came up with. Using our new technique, called feed-extended drilling, the stabilizers are not used. The bit is now in a forward position extended past the stabilizers. Moving the drill straight into a rock and retracting safely without the stabilizers is challenging. We move the arm instead of the feed mechanism to place the bit onto the rock and press it forward as it drills. After making contact, we apply a light preload and drill a shallow pilot hole. We use a force sensor in the robotic arm to give Curiosity a sense of touch. This lets Curiosity adjust its arm motion and avoid getting stuck while drilling, kind of like you might adjust your arm while drilling into a wall at home. After drilling, we use a similar technique to retract from the hole without getting stuck.
With Rover 2020 design and construction well underway, engineers will be sure to avoid such a problem with Curiosity's cousin, which will land in the Jezero crater in 2020. "2020 will be a banner year for the exploration of Mars. In addition to the launch of NASA's Mars 2020 rover, the European Space Agency and Roscosmos are sending the ExoMars rover to the Red Planet. Rover 2020 and its companion helicopter will no doubt expand our search for life, past or present. However, the big advance forward in organic analysis will be the game changer. Both rovers will carry on board a MoMA.
The Mars Organic Molecule Analyzer, or MoMA, is the largest and most complex instrument on the rover. Its mass spectrometer subsystem and its main electronics were built and tested at NASA's Goddard Space Flight Center, which also contributed mass spectrometers to NASA's Curiosity rover and Maven orbiter. MoMA is designed with a mix of proven hardware and innovative new technologies. Here's how it works. In gas chromatograph mode, crushed Martian rock is put into an oven and heated to 900 degrees Celsius in just 2 minutes, vaporizing the sample. Molecules of hot gas rise up and flow into a narrow 20-meter-long tube. Special coatings inside the tube cause molecules with certain chemistries to slow down more than others, separating the mixture of molecules over time. Next, a beam of electrons ionizes the molecules, giving them a positive electric charge and deflecting them towards the linear ion trap. The ions are caught by a fluctuating electric field and sent to a detector to determine the chemical makeup. While gas chromatography has been used to study Mars since the Viking program, MoMA has a second method for preparing samples that has never been used on another planet. In laser desorption mode, a sample is placed beneath a powerful ultraviolet laser. A beam of energetic light builds within the laser and fires in a billionth of a second, concentrating its energy onto a spot smaller than a grain of sand. This rapidly vaporizes a portion of the sample, releasing large organic molecules that could be broken down by oven heating. The laser shot also ionizes some of the molecules, allowing the vapor to head directly to the linear ion trap. Neutral molecules are ejected by a vacuum, while the remaining ions are sent to the detector to determine their chemical makeup. Laser desorption will enable MoMA to detect long molecules, like lipids, the building blocks of cell membranes, a leap forward in the search for life on Mars.
The question of life on Mars is among the most important in planetary science, and the evidence may be buried just below the surface. With the help of MoMA, we will take one step closer to uncovering the answer. These images will pave the way to a new understanding of life in our solar system.